Hello students. So let us continuing our lectures on mathematical physics. So today we shall be discussing about Fourier series. Now you can find Fourier series, a lecture on Fourier series in lecture number 165, and have a look. So this is actually a recap of what has been told there. So let us start now. Any single valued periodic function, it has to be a single valued periodic function and can be expressed as a summation of simple harmonic terms, expressed as a summation of simple harmonic terms having frequencies which are multiples of that given function. With frequencies which are multiples of the given function. So this is the Fourier series in words. What do you call the definition in words? But mathematically, let us try to understand what it is. So first of all, let's see that we have a function fx, which is defined in the interval minus pi to pi, and it has the period 2 pi, that is fx plus 2 pi gives you back the function fx. So if this is the condition, then you can expand fx as 1 by 2 a0 plus summation n is equal to 1 to infinity a0 cos nx plus b0 sin nx. So this a0, an and bn, these are the Fourier coefficients. So an is equal to 1 by pi minus pi to pi, the interval fx into cos nx dx, and bn is equal to 1 by pi minus pi plus pi fx into sin nx dx, where n can take value 0, 1, 2, 3. So this is how the Fourier transform is defined. So in the same notion, had it been that this fx was, instead of having in this interval minus pi to pi, if it was having an interval, say, between minus L to L, with the period 2L, that means fx plus 2L is equal to fx. Then fx would have been represented as 1 by 2a0 plus summation n is equal to 1 to infinity an cos n by x by l plus bn sin n by x by l, and where a0 an and bn an with a an would be equal to 1 by L minus L to L to fx cos n by x by L dx, and bn will be equal to 1 by L minus L to L fx sin n by x by L x dx. So this is the same way of writing the Fourier series. There is another way of writing the Fourier series, that is the Fourier complex form of Fourier series. So this is the complex form of Fourier series, and so you can write fx as equal to integration n is equal to minus infinity to infinity cn e to the power I n by x by l, where cn is equal to 1 by L summation c plus 2l into fx e to the power I n by x by L dx, and so it will be again equal to 1 by 2a0, where n is equal to 0, and it will be equal to 1 by 2 a minus n plus b minus n, where n is less than 0, and it will be equal to 1 by 2 an minus I bn, where n is greater than 0. So this is another form of writing the Fourier series. So based upon this complex form of Fourier series, we have something called a Fourier transform. Physically, Fourier transform means we are going from one space to another space. For example, if it is a from real space, say if x is the real space, we go to the momentum or the k space, or if it is a time space, we go to the frequency space. So this is Fourier transform is all about. Now the Fourier transform can be written as, say if fx is the function, the Fourier transform of fx is equal to, say, a function of a, and it is equal to this is called the kernel like in case of x, k is the kernel. In case of time frequency is the kernel. So it is equal to minus infinity to infinity fx. Oh, sorry, it's not. This is actually not the kernel. This quantity that is being added, is introduced. This quantity is actually the kernel. This one. This is actually the kernel. E to the power I alpha x. So this is the Fourier transform. Similar to this Fourier transform, we have an inverse Fourier transform as well. So the inverse Fourier transform, that means f inverse of f a that is equal to fx, and it is equal to 1 by 2 pi minus infinity to infinity f a e to the power I alpha x d alpha. This is the inverse Fourier transform. So here fx and fa they are known as Fourier transform pairs. So some of the typical Fourier transform pairs is, let's say, if fx is 1 by x square plus a square, or x by x square plus a square, and 1 by x, then the corresponding FA Fourier transform pair will be pi into e to the power minus alpha a by a, pi by pi I alpha divided by minus pi alpha divided by a into e to the power minus alpha a, and pi by 2. And similarly, we have value of fx and as e to the power minus ax, and then fa will have the value a divided by alpha square, so f alpha, not fa. So this is actually f alpha, sorry, not a plus a square plus alpha square, and again if it is e to the power minus a x square, and if it is x into e to the power minus ax square, then the corresponding f alpha value will be 1 by 2 root pi by alpha, pi by a, sorry, into e to the power minus alpha square by 4a, and it will be equal to root pi divided by 4a to the power 3 by 2 alpha into e to the power minus alpha square by 4a. So this is what is the Fourier transform. Similar to Fourier transform, we have Laplace transform as well. So your next is your Laplace Transform. Laplace transform of a function ft. If there is a function ft, then the Laplace transform of that function is called L. So L of ft, it is equal to 0 to infinity ft e to the power minus st dt, and is equal to say fs. So here fs is the Laplace transform of ft. So similarly, so we can write L of ft is equal to fs. We can also write ft as equal to inverse Laplace transform of fs. So let's see some of the ft and Laplace and inverse Laplace transform. So if it's a function ft, if it is it can be say 1, and so the corresponding fs will be 1 by s. If it is a t, it will be 1 by s square. Now if there are two functions, let's say we have a into f1t plus b into f2t, then the Laplace transforms again will be a into f1s plus b into f2s. And if the case is function is being multiplied, that means if it is a into f into a t, this is the case, then the Laplace transform will be simply the function of f s by a. And if the Laplace transform, if the function is e to the power at multiplied by ft, then the Laplace transform will be f into s minus a. There can be other functions as well, like can be t to the power n minus 1 divided by n minus 1 factorial. This can be a function, and a to the power at can be a function, sine at by a can be a function, cos at can be a function, sine hyperbolic at by a, and cos hyperbolic at can be a function. So the corresponding Laplace transform in this case will be 1 by s to the power n, where n is any number, integer, but from 0. In this case it will be 1 by s minus a. In this case it will be 1 by s square plus a square. In case of positive, it will be s divided by s square plus a square. Because of sin hyperbolic, it will be 1 by s square minus a square. Cos hyperbolic will be s divided by square minus a square.